Hello students, welcome back. Previously in section 1 we went through elementary differentiation, even though most of them are review. Now let's go to section 2, product and quotient rules. What are those? Well, here we go. This is a product rule, and this one down here is a quotient rule. Product rule first. It turns out that derivative of product is not the product of derivatives. It's not u prime times v prime. Instead, we get something more complicated, u prime v plus uv prime. And then, as for the quotient rule, maybe a bigger font will help. Look at the numerator. It's almost the same as the product rule, u prime v minus uv prime. Yes, this plus became minus, but otherwise the same. And as for the denominator, v squared, well, that v of x squared is so conspicuous that nobody misses, actually. The denominator squared all the time. And for the numerator, it's exactly the same as the product rule except for the sign. And as for the sign, why do we have so sign difference? Well, this is multiplication, so plus. This is division, so we have to go inverse, minus. And by the way, some people do it this way. Rewrite it as u prime v plus vu prime, and this one as vu prime minus uv prime, like this. But I don't like these expressions very much. I don't, because if you look at this quotient rule, there's no resemblance between this one and that one. I mean, this one and that one are the same because multiplication and addition are both commutative. And also you can easily check this and that are the same as well. But the problem is, this and that look very, very different. So different that you have to memorize two completely separate formulas. And that's not an efficient way to study. You have to cut down the number of things to memorize. So how do we do it more effectively? Right here, u prime v plus uv prime, get that one, and you get exactly the same expression over there, u prime v minus uv prime. And the denominator squared, that's so conspicuous that nobody misses actually. Okay, so much for product and quotient rules, and let's discuss how to use those. Alright, here's the first problem. And this one is going to be better if I rewrite it in the power form. Okay, all right. Now, what is the derivative function? Well, it's a product, so we have to get product rule. U prime v u v prime, like this. Now, as for this v, this is not a derivative problem. It is just copying and pasting, just same as v. And then, as for this u, it's just copying and pasting. Now, we have to fill out this derivative and this derivative. Basically, we reduce one large derivative problem into two small derivative problems. Let's do the first derivative. Derivative of the first function. It is 1 plus e to the w power, right? Next, what is the derivative of the second function? It is 0 minus 1/2 w to the negative 1/2 power after subtracting 1 from the power. And then you can throw away this 0 minus. In any case, there you go. No need to simplify. That's the answer. Here's the answer key. Here's the structure. You have to fill out this blank, u prime, and this blank, v prime. How? Like this. Now the next problem here. How to do this? Well, before anything, my first suggestion is to use power form conversion because it's difficult to calculate any derivative like this. So rewrite it as 4 s to the negative third power, and this one is going to be s to the 1/2 power because square root is 1/2 power, and this time square root is in denominator, so s to the negative 1/2 power. That's the power form. And then you can apply the product rule. Good luck. Well, that's basically the structure. U prime v plus uv prime. U prime v, well, that's not a derivative computation, it's just copying and pasting. And u, that's just copying and pasting too, no derivative computation. And this one is derivative. Now, fill those in. This one, let's go ahead. 2s plus 3 minus plus 12s to the negative, subtracting 1 from the power, what do you get? Negative 4 power. Common mistake is to do this because 3 minus 1 is 2, but negative 3 minus 1 is actually negative 4. Now, how about this one? 1/2 times 4 is 2, and subtracting 1 from the power, we get negative 1/2 power. Now, negative 1/4 times negative 1/2, oh, that becomes positive 1/8 s to the, now subtracting 1 from the power, we get negative 3/2 power. I guess that's it. Did I make any mistake? Well, there's one way to check. Alright, here's the structure. And what goes into those brackets? Yeah, like this. Okay, the third one is left to the students. Now let's go to a quotient rule. Now, what's the derivative? Well, first of all, the denominator squared. And as for the numerator, we need u prime v minus u v prime. U prime v, what's the denominator here? E to the 4th power minus 2. And u here, t cubed plus t. Oops. Sorry about the typo. And then we have to fill out this derivative here and this derivative there. Maybe a little bit bigger font will help. Now, what's this derivative here? Derivative of the numerator. 3t plus 1. Is that clear? And how about the derivative of the denominator? 4t minus 0, so I don't really need minus 0 there. That's it. Okay, let's check. Okay, that's the structure, and fill out the derivatives. Okay, let's do this once more. This problem here. Okay, the derivative is, first of all, denominator squared. This one is so conspicuous that nobody misses actually. Oh, by the way, here is the quotient rule, u prime v minus uv prime over v squared. So, okay, u prime v, which is x plus log of x, and u, x squared plus e to the x, and then v prime. Alright, what derivatives do I fill in? Derivative of the numerator here. 2x plus e to the x power. How about here? Derivative of denominator. So this is 1 plus the derivative of log function, 1 over x. Or if you prefer the power form, you can write like this. Either way, it's correct. Me personally, I prefer power form. Here's the answer key. Yeah, that's the structure of the quotient rule. And then filling in, we get this.